Far beyond Neptune, in the frozen edge of our solar system, there is a dwarf planet that seems to break every rule. It spins so fast that it basically has an egg shape rather than a round sphere, as if gravity can barely keep up with its speed. No one expected a planet like this to exist, but yet it does. You see, in 2004, two teams were watching the same patch of sky, one in Spain, one in California, both tracking distant points of light beyond Neptune. And within months, both realized they had found something unusual. It was moving too fast to be a background star, and too bright to be a typical Kuiper Belt rock. When the orbits were calculated, both groups realized they were looking at the same object. But before they could even agree on what it was, arguments started. They argued over who saw it first, or who deserved the credit. But what really mattered was what this strange planet was doing. Because when astronomers looked closer, the numbers made no sense. It wasn't round, like Pluto or Eris. It was stretched, almost egg-shaped. And based on its brightness and spin, it seemed to be rotating once every 4 hours, faster than anything its size had a right to. For the first time, scientists realized they might be looking at a world spinning so violently it had literally pulled itself apart. This dwarf planet, known as Haumea, spins faster than any other known world of its size. A single day there lasts just 4 hours. That speed is so extreme that gravity can barely keep the planet together. Instead of pulling itself into a perfect sphere like most planets, it's been stretched thin across the middle. To make sense of that, scientists started looking for what could have caused it to be like this. And the most likely explanation is violence. Billions of years ago, Haumea was probably hit by another large object, a collision powerful enough to send parts of it flying into space. The core survived, spinning faster from the impact, while the outer layers were ripped away. When astronomers studied Haumea more closely, they noticed something strange about how it reflected sunlight. Its surface was unusually bright, almost as reflective as fresh snow. That didn't match what they expected from an old, dark, icy rock drifting billions of kilometers from the sun. Spectral scans revealed the reason why. The entire surface is coated in crystalline ice, the same kind found in the outer layers of its moons. That clue tied everything together. The impact that spun Haumea into its current shape also resurfaced it, exposing cleaner, younger ice from deep below. Over time, that ice should have darkened under radiation, but somehow it hasn't. One theory says tiny impacts from micrometeorites or internal heat could be refreshing the ice, slowly turning it over from beneath. Another suggests that the planet might still have traces of radioactive decay in its core, just enough to keep parts of it active after billions of years. That's what makes Haumea stand out among the dwarf planets. Where Pluto has a thin atmosphere and Eris stays frozen solid, Haumea looks alive in motion. But as if Haumea's shape and speed weren't strange enough, in 2017, astronomers spotted something no one expected. When the dwarf planet passed in front of a distant star, the starlight dimmed twice. Once as Haumea itself blocked it, and again just before and after. That second dip meant only one thing. Haumea has a ring. A ring around a dwarf planet more than 6 billion kilometers from the sun. It's the first object of its kind ever found with one. That ring sits just outside Haumea's equator, orbiting in perfect sync with its rapid spin. It's thin and likely made of icy debris, fragments that may have been thrown off the surface long ago during the same collision that shaped the planet. What's even more interesting is how stable it seems. Even though Haumea's rotation stretches and flattens it, the ring doesn't collapse inward or drift away. It moves in rhythm with the planet, locked into a balance that shouldn't even be possible at that scale. To this day, scientists are still trying to explain how such a small world maintains a ring system so clean and persistent. Some believe that faint gravitational interactions with its two moons help keep the material in place, forming an invisible tug-of-war that holds the system together. Now, even though we don't have many clear images or direct data from Haumea itself, the closest we've gotten is this one, which was caught by the Hubble telescope in 2015, with Haumea in the center and its two moons, Namaka and Hi'iaka. What we do know comes from how it moves, how it reflects light, and how its moons orbit around it. Every bit of information points to a world that refuses to fit into any of the categories we've built for planets. It forces astronomers to rethink what a planet really is. It doesn't fit our neat categories. It's not round, and it doesn't behave the way a stable world should. Yet it's held together by the same physics that shape everything else. It lets us know that the solar system isn't made of perfect examples. It's a spectrum of extremes. Some planets form slowly and stay quiet. Others, like Haumea, spin themselves into something unrecognizable but still manage to survive. If you like this breakdown, then you're going to want to watch these other videos. Thanks for watching.